This section is 9.4. I know in the last section I said 9.3 would take us several days to complete. I was mistaken for the mere fact that I was thinking that these two sections, 9.4 and 9.5, were actually part of 9.3. So this section here is what I was going to extend into a second part of 9.3. So just so we're on the same page with that. So this section is referring to how we solve quadratic equations. So it's still the same stuff that we were doing in 9.3, except for instead of using the square root method, now we're not going to be able to. Okay, so that's what this first line says. Previously, we were looking at this equation. We had an ax squared plus c equals 0. And we use the square root to eventually solve for x. In 9.4, we changed a little bit. Now we're going to work with an equation of this form where we have that bx term now. Okay, so because of the inclusion of that term, that's what's different between this and that. Okay, with the inclusion of that term, the square root method does not work. So we have to use what we call our factoring techniques or our factoring methods. Okay, so in order to be able to do that, one of the key concepts is what we call the zero product property. Okay, product obviously means multiplication. Zero is the product that we get when we do multiplication. Okay, and so here's what the product says, or the property says. It says if a times b gives you 0, if a times b gives you 0, and a and b were both real numbers, okay? So any number that we choose off the number line, but when we multiply them together, we get 0, that must mean that either a or b, or maybe both, were actually 0 themselves. So here I'm telling you, I've got two numbers, I don't know what they are, a and b. But when I tell you I'm going to multiply them together, and I get a product of 0, that tells you either that number was 0 or that one. Okay. Here's my next question to kind of piggyback off that. Let's say that I have two numbers that multiply. Let's just say to give me 6. Let's say a times b equals 6. Okay. You really can't tell me what either of these numbers are going to be. This one could be 2. That one could be 3. Or it could be flip-flopped. Or a could be 1 and b could be 6. A could be 6, b could be 1. Okay, and those are usually the ones that most people think about. But I could also say a is 12 and b is 1/2. I could say a is 24 and b is 1/4. I could say a is -2 and b is -3. There's actually an infinite number of things that I could create here, of real numbers that I multiply together to get that 6. Okay? Where if I say a times b is equal to 0, a might be any number, but if a is any other number other than 0, you know for certain that b is 0. Or b could be any number, and if their product is going to be 0, then you know a had to be 0. So it kind of dwindles our options for these two values when I know that the product is 0. And that's a key concept that we're going to use here when we work with this quadratic with the bx term incorporated. Okay, still going to have the number of solutions that we had. There's still a quadratic equation, so the same solutions I talked about in 9.3 are going to exist here. So you can have 0 solutions, 1 solution, or 2 solutions. And graphically, again, it's where the parabola crosses the x-axis. Okay. I just went ahead and put some steps here. I'm not a big steps person. I think you guys have witnessed that and realized that through the course. But if you get in a little bit of a sticky situation, not sure what to do, these steps can help. The one thing that you're going to have to do initially is make sure that you move all your terms to one side. Okay, so when you move all your terms to one side in your equation, it's going to leave you with one side equal to 0, and that's what we want. We have to, in order to factor and use this zero product property, we have to make one side of the equation 0. Okay. The second thing you're going to do, and these two things can be all done in the same step. I just kind of broke them up. You're going to write your polynomial in descending order. Remember, that means from the largest exponent to the smallest. Okay. So from picking up from there, I just kind of went ahead and did an example here, okay, to talk about. So you can only continue if your equation looks similar to this example here, okay? If you still have numbers over here or other variable terms or whatever, you cannot proceed. You have to get your quadratic equation looking like this. There has to be a 0 on that side, okay? So step 3 then is to take this side here and remember what we did in chapter 8 when we factored it, okay? Remember, we're looking for two numbers that multiply together to give me 6 and add up to give me 5. And those two numbers are 3 and 2. So I factored that left-hand side like this. X plus 3 times x plus 2 equals 0. And now here's where the 0 product property comes in. This is a number. When you know what x is, let's say x is 7, then that number is 10, and that number is 9. If x is 5, that's 8, and that's 7. But if those are the values for x, and when we multiply them together, I don't get 0. So let's go back to x being 5. If x is 5, I get 8, and there I get 7. So 8 times 7 is 56, not 0. Okay? So I know that x in that case could not have been 5. Okay? The only way that I can get 0 here, because I'm taking these two things and multiplying them together, is if that one there was 0. So what do I need to use for x to make this thing 0? I have to use -3. So if -3 was the x value, -3 plus 3 would be 0. That would be 0 right there. If I plug -3 in here, this would be -1. So I'd have 0 times -1, and that does give me 0. So one of my answers for x would have been that -3 that I put in there. And I'll talk about how we get that -3 here in a moment. -2 would work again. If I put -2 in right here and right here, this turns into a real number. So -2 plus 3 would be +1. And this would give me 0. So I have 1 times 0, and that gives me 0. So my second answer would be -2. Okay, so that's kind of the logic behind these next two steps. So at this stage, once you factor it like this, you're going to apply what we call the 0 product property. Okay, if you know you're multiplying two numbers together and you get 0, then that means either the first number was 0, so this is the first number, right? It's just an algebraic expression that represents a number. So we say either the first number is 0, or the second number is 0. Note that once you substitute a value in for x, these parentheses are actually, like I said, they're real numbers. Okay. Now with the two smaller equations, so once you do this, you get two smaller equations essentially. Okay, so that's x plus 3 equals 0. You can get rid of the parentheses. X plus 3 equals 0, and x plus 2 equals 0. If you solve those are just one-step equations, solve them both for x. Solve this one for x, you get x to be -3. Solve that one for x, you get x to be -2. And those are the two places then where your parabola is going to cross the x-axis. Those are your solutions to the equation. Okay, those are the only two numbers that when I plug back in here. So think about plugging in -3. If I plug -3 in right here, I get -3 squared plus 5 times -3 plus 6. So -3 squared is 9. This is -15, and that is plus 6. If I evaluate that, it indeed gives me 0. If I try -2, -2 squared plus 5 times -2 plus 6, that gives me 4 minus 10, so that's -6, plus 6 gives me 0 again. Those are the only two numbers, -3 and -2, that do that. If I plug in like a number, let's say, let's plug in 1. Maybe I think 1's my answer. So I go 1 squared plus 5 times 1 plus 6 equals 0. Well, that's 1 plus 5 plus 6 equals 0. Does 12 equal 0? No, that's a contradiction. That's false. Okay, so that's why 1 was not an answer. Okay, the only two that give me 0 as a result when I substitute back in are -3 and -2. That's the logic of what this process is all about here. Okay, so just kind of working through some examples with you that you're going to see. I think I got like 12 examples here. We'll see if we go through all of them or not. First ones here are relatively kind of basic because the factoring is really already done for us for the most part. Missed a parenthesis here for some reason. But what we've already broken this down from something else. So the first couple in your homework you're going to see this way, and it's just targeting that, well, if I know these two things are being multiplied together and I get 0, then that means 3x plus 2 is equal to 0, or 5x minus 1 is equal to 0. And now I've got these little equations I can solve. So I'll subtract 2 from both sides, and I'll divide both sides by 3. So -2/3. Here, I'm going to add 1 to both sides, so you get 5x equals 1. Divide both sides by 5. X equals 1/5. A couple different ways you're going to see your answers written. Sometimes they'll just say, and they'll have a box and say type in your answers. Sometimes, because there are multiple solutions, and we've talked about this in the past, you'll put that curly brace, and then you'll put your two solutions with a comma in between them, and then finish with another curly brace. And then it just tells you that both things inside those are solutions. Okay, this is really the same thing, but it's a little bit confusing for some people because they're not sure about what that is right there. Okay. The way I approach this is initially when I teach this is that when I just see an x out there, you can write it this way: x plus 0, and then 3x minus 3. If those are the things that I'm multiplying together to get 0, that means then that x plus 0 is 0, or 3x minus 3 is equal to 0. Well, when I solve for this one, it just gives me x equals 0. When I solve this one, I'll add 3 to both sides, and then I'll divide both sides by 3 here. It gives me x to be 1. So my solutions, curly brace, 0, comma 1, curly brace. I'll jump down to this one. Actually, no, let's go ahead and do this one, because this one kind of piggybacks off of this one. This one was already factored for us. This one we've got to do a little bit of work here. So this one here, there's a GCF here that we can factor out. If you look at it, they both have a 5x in them. That has a 5x, and that has a 5x. So when I factor that out, it gives me x plus 1 left over. Just a quick check of that is to distribute. Does that give me 5x squared? And does that give me 5x? Okay. So now I know, this is one factor. This is my second factor. They're multiplying together to give me 0. So that first factor is equal to 0. Or the second factor is equal to 0. Divide both sides by 5 here in this equation. So I get x to be 0. 0 divided by 5 is 0. Here I'll subtract 1 from both sides. So using x equals -1. So those are my only values, 0 and -1. That would be solutions. This next example, again, this is kind of, like I said, where you're going to start off with in your homework. You start off with these, and then it'll put in a couple of these, like this first one, and then maybe a handful of these here, and then we'll get into these other ones as well. But again, we've already factored this, so we'll set that one equal to 0, and we'll set that one equal to 0. And go through and solve. So I'll subtract 1 from here, and then add 5 here. So my solutions are -1 and 5. And again, so what that means to us, just remember, it means if I have a parabola, that's -1, 1, 2, 3, 4, 5. Okay, my parabola is going to pass through those 2 points on the x-axis. The next one, same idea. Okay, it's already factored. So x minus 3 equals 0, or x plus 7 equals 0. Add 3 to both sides. Here, I'm going to subtract 7 from both sides. So my solutions are 3 and negative 7. Doesn't really matter the order that you type your solutions in. Now this next example is going to incorporate a couple more steps. So the first thing, if you remember, we said that that number had to be 0. So I need to move that to that side, okay? So I'm going to use the inverse operation. So I add 5 here, and then add 5 here. So combining like terms, it's going to give me x squared minus 11x. Positive 19 plus 5 is positive 24. Gives me 0. Now, remember what we're doing. We're looking for 2 numbers that multiply together to give me 24 and add up to give me negative 11. So if I'm thinking about those numbers, so 24, I go 1 and 24. Now they both need to be negative because they need to add to give me a negative number and multiply together to give me a positive. Those don't give me negative 11. I try negative 2 and negative 12. That doesn't give me negative 11. I go negative 3 and negative 8. Those add to give me negative 11. Those multiply together to give me positive 24. So that's how this factors. X minus 3, x minus 8 equals 0. Okay, so now what we're looking for, we've got the 0 product property here. We can take the x minus 3, set that equal to 0, and the x minus 8, set that equal to 0. Solve both those, gives me x to be 3 and x to be 8. So those are my solutions. And I just want to go and look at this real quick in Desmos. Now, obviously, I'm not going to use the x. I'll use a different letter, use a. So let's say a squared minus 11a plus 19. So what I'm going to do here is I'm going to say a, I want it to be 3. And you see that if I plug a to be 3, it gives me this negative 5 right here, which was the right-hand side of my original equation. If I plug in 8, see if I get that negative 5 as well, and I do. You will notice that any other number does not give me the negative 5. So if I tried 5, it gives me negative 11 back, which is not that. So this is not a 5 is not a solution to this equation. Okay, so that's nice. I like to go back to the original equation to check myself. But you could have, if I just wanted to go to the a squared minus 11x plus 24. And then said, okay, well, what do I do if a, in this, I don't know why I put an x there as a. What happens when a here is 3? You see now you're getting the 0 that is established in this equation here. If I try it to be 8, you see again that I get the 0. So just keep going through. Try to give you as many examples here as possible. Okay, so first step, make sure that everything is moved to one side. So I get to take that, and I got to subtract it from both sides. So minus 5 there, minus 5 there. So we get x squared plus 7x plus 10 equals 0. Okay, so we're looking for 2 numbers that multiply together to give me 10 and add up to give me 7. So those are 5 and 2. So now I'm going to use my zero product property. So x plus 5 equals 0, or x plus 2 equals 0. So x equals negative 5, x equals negative 2. This question here, I'm going to now, because it's a minus 2 over here, I want that to be a 0. So I'm going to add 2 there, add 2 there. So we get x squared minus 10x plus 24 is equal to 0. Two numbers that multiply together give me 24, and add to give me a negative 10. Those are going to be negative 4 and negative 6. Now I can use the zero product property. So x minus 4 equals 0, or x minus 6 equals 0. Add 4 to both sides. Get x equals 4. Add 6 to both sides. X is 6. 4 and 6 are those two solutions. Same steps. So I'll subtract 6. X squared plus 3x. Now negative 12 minus 6. Negative 12 minus 6 gives me negative 18. So we'd be looking at what? 6 and 3. So x. Okay, so I'm looking at negative 18. 6 and 3 multiply together give me 18. One of them's got to be negative to give me negative 18. And to add to 3, this one's got to be the negative one. So it'd be x minus 3, x plus 6 equals 0. So now I can say x minus 3 is equal to 0, or x plus 6 is equal to 0. Add 3 to both sides. Here I'll subtract 6 from both sides. So 3 and negative 6 are my two solutions. And these last three here, just try to give you a little bit of variation in these. It doesn't always have to be a constant on this side that we've been moving. Everyone has been so far, but it could be anything, okay? And it could actually be a series of things. I could have like a plus 4 here, and I have to move all that stuff over. I don't think there are too many questions, if any, that do that in your homework right away. But whatever you have to do to make this side 0, whether it's moving 1 term, 2 terms, 3 terms, 4 terms, whatever it may be, you've got to do that. So I'm going to subtract 3x. Now I'll come over here, and I got to find the like term that 3x goes with. So it'd be that one. So I have x squared. 5x minus 3x is positive 2x. And then my minus 35 is equal to 0. And after that first step, it's the same exact thing as before. Two numbers that multiply together give me negative 35, and add to give me 2. So that's going to be x minus 5 and x plus 7. I know as we're doing these, I'm going pretty fast finding these factors. Those are things that, you know, if you've got to sit down and go, okay, 1 and 35, 2 doesn't go with anything, 3 doesn't go, 4 doesn't go, 5 and 7. If you got to do that, write that list down, go ahead and do it. Okay, I'm skipping over that a little bit. Okay, so now we got that product giving me 0, so that means x minus 5, whatever that number is 0, or x plus 7 gives me 0. So this will be, I'll add 5 to both sides. Here I'll subtract 7 from both sides. And just real quick, and I think it makes sense to maybe talk about this at this point now. If I plug 5 in, okay, think about, and I want to plug into this right here just to prove this zero product property. If I plug 5 in right here, that becomes 0. That number becomes, so 5 minus 5, that gives me 0. And this gives me 12. Well, what's 0 times 12? It's 0. Okay. If I plug negative 7 in, I get negative 7 minus 5 gives me negative 12. When I plug negative 7 in here, negative 7 plus 7 gives me 0. What's negative 12 times 0? 0. So that's kind of what's going on in that zero product property that is allowing us to generate these answers. The next one, so the next one's already got 0 over here, okay? But if you look at the structure of these, the A term is different than all the other examples we've done. All the other examples that we had to factor, okay? So starting with, this one right here, okay, starting with that one, all the way through so far, we just start factoring it away. Remember, though, when we talked about in Chapter 8, that if that number is not a 1, we want to go through and see if I can divide everything by it. And in this case, I can. Okay? So 3 divided by 3 gives me 1, so I get x squared. Negative 9 divided by 3 gives me negative 3. Negative 12 divided by 3 gives me negative 4. And then the right-hand side, 0 divided by 3 gives me 0. Okay? So now does that factor? Well, are there two numbers that multiply together give me negative 4 and add up to give me 1? Or sorry, add up to give me negative 3. Multiply together give me negative 4, add to give me negative 3. Those are negative 4 and positive 1. Those are two numbers that do that. So then I take x minus 4 equals 0, or x plus 1 equals 0. So x is 4, add 4 to both sides. Here I subtract 1 from both sides. So negative 1, 4 are my solutions. This next question, same approach, okay? I'm just seeing that the reason I put this one on is instead of, that's even, that's even, that's even. They're all going to be divisible by 2. But I like that number out front to be a 1x squared, a positive 1x squared. So instead of dividing by 2, I'm actually going to divide by negative 2. And that's something to think about as you do this stuff. If that's a negative number that you're going to divide out as the GCF, do it, okay? So it gives me 1x squared. Negative 2 divided by negative 2 is positive 1. Negative 6 divided by negative 2 is positive 3. And positive 80 divided by negative 2 is negative 40. All right, so now we're thinking about two numbers that multiply together to give me that's negative 40. Two numbers that multiply together give me negative 40, but add up to give me positive 3. Was that 8 and 5? 8 times 5 gives me 40. If the 8 is positive and the 5 is negative, those should add up to give me positive 3. So I'm looking at x plus 8 and x minus 5 equals 0. Okay. Take the x plus 8, set that equal to 0. Take the x minus 5, set that equal to 0. Subtract 8 from both sides. Gives me x equals negative 8. Add 5 to both sides. X equals 5. Okay. I'll stop there with examples. In your homework, you're not going to, I think I got 15 questions up there. You're not going to see anything more difficult than anything that's in here. If you are struggling with this or you're confused about this, go to YouTube, type in, solve quadratic equations through factoring, and you will find a immense amount of additional resources, different examples, different explanations. Something to think about on your assignments. I have unlimited submissions on those questions or similar exercises. So I've gotten a couple people say I've gotten bad grades on this stuff. You shouldn't be getting bad grades. Okay. You've got unlimited chances to type in answers, put in answers. Now, if you get to the point where you've done it 3, 4, 5 times, and you're not getting anywhere with it, that's when you send me an email and say, "Hey, help me out with this question. I'm getting stuck. Here's my work," that kind of thing. Okay, so please, 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 make sure you're doing those things to benefit yourself. This stuff's not going to go away. This is
This is by far one of the most important things you're going to learn in Algebra 1. That is used again then in Algebra 2. It's used again, and you'll use it almost, I don't want to say immediately, but by the second quarter of geometry, you're using this stuff kind of on a consistent basis. So very, very necessary algebra here.